In this lecture, we will talk about change of base formula. Why do we need to do that? We know for log base 10 to the 5, the calculator can do it. Look, you can input log and then 5 close parentheses. You hit the enter, you have the answer. That's about 0.69897, something like that. If the base is e, and then you know that's natural log, so you may do is natural log 5 close parentheses. That's 1.6094. Okay, round 7 up to 3. Now, if a base here is 2, is no longer 10 or e, then we are not able to calculate log base 2 to the 5 equals what? So then it is necessary for us to change this base 2 to the different, maybe base 10 or base e. Okay. Now we know logarithm log base 2 to the 5 is actually the exponent. Yeah, log something to the something is always defined as the exponent. Exponent of what? Exponent of this base 2. So this base 2 to the w is 5. That's by definition. Okay. So you always end up with the exponent. Exponent of 2 to the w equals 5. That's by definition from here to here. Now we want to choose log base a. This a can be 10, can be e, can be 3, can be 4, can be 5, can be anything you wanted. But the thing is that the calculator does not have a base 3. It only has base right here, e, and here base 10. So if you change it to base 3, it's fine, but the calculator is not able to handle that. Okay. So anyway, a here can be anything. Choose logarithm, and then on both sides, and then remember, by the property of the logarithm, the exponent on 2 can be brought down to the front. Okay, so w brings down to the front is w times log base a to the 2. The right hand side is still log base a to the 5, because we only bring w down to the front. Okay, yeah, from here to here is both sides choose log base a, and from here we only bring w down. Now both sides divided by log base a to the 2, log base a to the 2, so we may cancel this 2. We may cancel this 2. Okay, then we end up with w equals log base a. The left hand side, the same number, log base a to the 2 divided by log base a to the 2, that's 1. So that left hand side has only w left over. Right hand side, it has log base a to the 5 over log base a to the 2. So we end up with w equals that. Okay, good. Now recall what was our W? or W here is this number. Okay, that's log base 2 to the 5. So you, instead of put W, you put log base 2 to the 5. Okay, right here. So you can see log base 2 to the 5, this was our W, equals log base A to the 5 divided by log base A to the 2. And here there are two situations right here. A can be 10 and A can be E. If A is 10, so then you don't need to write 10, because by default, if it's 10, you don't need to write. And then if base is E, if A equals E, then you know this log base E can be written as natural log 5. If here is E, A equals E, you can just simply write log base E as ln. Okay, keep 2 and keep 5. Are those two equal? Sure, they are equal. They are equal. You see, log base 2 to the 5 equals this number divided by that, also equals natural log to the 5 divided by the natural log to the 2. You can do this by using calculator. You see, log 5 divided by log 2. What do we get? 2.321928. That's this number approximately. You can also do this one. Log 5, that's natural log, divided by natural log 2 here. You hit enter, you get the same answer. Here is A equals 10, A equals E. A can also equal 3, okay? A can also equal to 3. Equal to 4, 5. Whatever, they are all equal. Okay. Now, this is the very concrete example. In general, if you have W equals log B to the U, then you have a B to the W equals U. Why? Again, log base B to the U equals W. W is always the exponent of B. So B to the W equals U. That's by definition right here. Same reason. Okay, by definition. Yeah. Now here they are parallel. Look, they are parallel. And then you may choose log A. Choose log A on both sides. So if you choose log A, B to the W, you choose log A, and then to the B to the W. That's left hand side. Right hand side, you do the same thing. Log base A to the U. Okay. And then again, you may bring this W down to the front. Okay, like the one right here. So you bring down, it was exponent operation, now it's multiplication. Okay, and then divided by log base A to the B, log base A to the B, like the one here we did. You may cancel that. Okay, cancel that, cancel that. So left hand side has W left, right hand side has log base A to the U divided by log base A to the B. Okay. Again, what was our W? The W is the W here, is the W here. Okay. So then you want to do is, this was our W, W, W. So this is also W. And then instead of put W here, you put log base B to the U. That's our W. and then right hand side you keep it, that's this one, and then this is the formula. Okay, log base b to the u equals log base a to the u over log base a to the b. And then here again a can be equal to 10. Then if a is 10, you don't need to write it. Left hand side are the same. Right hand side, if it's 10, don't need to write. If a equals e, then log base e is just ln, natural log. Log base e again is the natural log. So u over log base u over log base b. Again here a can be what? Can be 3, can be 4, can be 5, can be 100. They are all equal. Okay. The thing is that if you put 3, 4, 100 here, the calculator is not going to work. The calculator can only have natural log here and the log. Okay, that's the thing. Now here there is a note. There is a note. The formula here is different from those two. We need to be aware about. Okay, you see right here log base a to the u whole log divided by log base a to the b. So this one does not equal log base a to the u divided by b. They are not equal. Why? You have an example here. For example, a can be 2, u can be 8, b can be 4. We know log base 2 to the 8 is 3. Log base 2 to the 4 is 2. Okay. 3 divided by 2 is 1.5. Now right hand side here, if u is 8, b is 4, 8 divided by 4 is 2, and then log base 2 to the 2 is 1. 1 apparently is not 1.5. Okay, so this formula is different from this one. That's one thing. Another thing is that you may recall, division is subtraction, but remember they are different. Okay, here the division, one log divided by another log, is this one. A disappeared. A disappeared, and u b still there. Denominator, this b x will be a base. This u is b to the u. This one again is also different from that. You see, you can plug in actual number as we did here. A again is 2, u can be 8, b can be 4. Okay, so this one again will be 1.5 on the left. Right hand side, 8 minus 4 is 4, and then log base 2 to the 4 is 2. Okay, 2 apparently is not 1.5. So this formula is different from those two. Okay, and again this formula is that you have a b to the u log in front of it, and then you can put any a here. A can be 10 and e, those are two popular values, but a can be 3 also, can be 4, can be 100. When you go from this left to the right, you can add a, but once you go from the right to the left, a disappeared. Okay, and b to the u. So there are many variations for this one. We got to be careful. This formula is used widely, and this formula is called change of base formula. base from B to any basis you wanted. Okay. Please review this lecture. I'll see you next time.